Operations on sets. First is complement of a set. Now if A is a subset of universal set, the complement of the set A is denoted by A dash or AC. So what do you mean by this complement? Complement of a set means that the elements which are not occurring in a particular set. In simple, for example, if universal set is 1 to 10, then from that universal set we have made one set A. In set A there are values 1 to 5. So which elements are not there? 6, 7, 8, 9, 10. That is known as A complementary, or we can say complement of a set. Then union of sets. Union of sets A and B is set of all elements which are there in A or B. Here OR is taken in the inclusive sense. So remember, all those values which are there in A or B, OR is quite important here. Remember this OR. So the values which will contain in A or B, here you can use a symbol like this of U, of A union B. For example, if A has a values 1, 2, 3, 4, B is having 5, 6, 7, 8. So A union B will be all the values like 1, 2, 3, 4, 5, 6, 7, 8, irrespective whether they are common or not. Then there is intersection. Now here in intersection, we will take the values which are there in A and B. Here AND is important and here OR was important. So AND, for example, if A has the value 1, 2, 3 and B is having the value 3, 4, 5. So here what is common here in both the value, in both the sets? Obviously 3 is there in A also and in B also. So here we can write A intersection B as 3. So remember this important terms. Now there is one distributive property. Some important properties are given to you. You just have to remember these properties. First is A intersection into B union C will always be equal to A intersection B, then close the bracket, union A intersection C. So the intersection of AB and AC and the union means the values which are contained in both the part will always be equal to this one. Then A union into B intersection C. Now here all values will be same, just the sign we have to change here. That here it was intersection, so here there will be union. Here outside there was union, so here will be intersection. So here A union B, and then close the bracket, intersection A union C. So the combination what we get in A union B and A union C, and the value which is there common in both the part, we will write here as A union into B intersection C. Just important distributive property which we have to learn. Then there is DeMorgan's law here. Here if A and B are subset of a universal set, means A and B are a part of the universal set, then A union B complementary is always equal to A complementary intersection B complementary. So the values which are not there in A and B, and if they intersect, it will be always equal to the union of AB and the value which are not there in A and B. Then A intersection B complementary with the value which are not there in A, B in common. So how to find that? A complementary union B complementary. So the values which are not there in A and B, take them together, you can find A intersection B which is not together, which is complementary. Even this is important law, you have to remember this law, which will be helpful in solving the questions. Then difference of sets. Difference of set A and set B is a set of elements which are in A but not in B. Remember this part. It is denoted by A minus B or A dash B. The shaded portion in the figure represents A minus B. Thus A minus B is equal to, see this diagram carefully. If you see, this is a universal set. two Venn diagrams are given, one is A and one is B. Now here we have to find all those elements which will be there in A but not in B. So if you see this mid part consists in both the sets, in A also, in B also, and this B is definitely entire part of B. So we will exclude this part, this intersection one plus whatever is there in B. So we are left with the shaded portion. This shaded portion represents A minus B, the difference of A and B, and here it is B minus A. So let's take one example. If in A there are values like 1 2 3 4 5 6, in B there are values 2 4 6 8, then A minus B, the elements which are there in A but not in B are 1 3 5. So here A minus B we can write as 1 3 5, and B dash or B minus A you can write as 8 here. So this is how you have to find difference of sets. So here you can read X is an element, or X belongs to A, but X does not belong to B, means it will be in A but elements will not be there in B. That is known as difference of sets.